Hi, my name's Lachlan. I've just finished a PhD in physics at James Cook University. I did my undergraduate bachelor's degree in mathematics and physics here at JCU. I went on to do an honours in statistics and 3.5 years of a PhD in physics. My PhD was concerning satellite remote sensing of water quality parameters in the Great Barrier Reef, and so that's sort of been quite neat. It's been a combination of applied physics, algorithm development, field work. So I've spent a fair bit of time out on boats, floating around in amongst tropical islands, and then a fair bit of time in the office crunching numbers. Initially, I probably wasn't attracted to mathematics to start with. I was going down the road. I wanted to be a meteorologist originally. And I got to university and they said, well, if you want to be a meteorologist, you've got to be good at physics. And to be good at physics, you've got to be good at mathematics. So I guess I sort of took a deep sigh and went, okay, I'm just going to have to live with that. And actually, yeah, I guess I enjoyed maths at school, but probably I didn't initially see myself heading down the career path of a mathematics-based profession. And now I sort of got into my undergraduate and went through the motions. I guess maths is neat because you can pretty much explain most physical phenomena in the world with mathematical relationships. I mean, everything from kicking a football through a goalpost right down probably to the sound system we're using here and the signal processing you'll be using to take out any high frequency interference. It's all mathematics. So I guess we take for granted how much mathematics goes into our everyday life. So I think that's what's neat about it. I guess I probably should be saying that I was inspired by my teachers, but I guess at the time I didn't really see myself going down the path of mathematics in my future. And I guess in retrospect, I came from a small town, and had I thought or had I been introduced to the concept of where mathematics might take me, I probably would have been a lot more excited about the future prospects. Well, I find it's interesting when you contrast your high school teachers to university lecturers. And I mean, I found with university lecturers, some of the best mathematics lecturers I've had have done a lot of different things in their careers, and so they can always relate solving a particular problem or an equation back to something in the real world or something that you can actually look at directly. And whereas I guess for maths teachers it's a little bit different. It's a little bit difficult, and so I guess having a bit of a feel for real world applications and where the quadratic equation is that you're trying to teach the children comes from and where it's applicable to probably would make a big difference for kids, especially who always throw back the answer or the question to you, where am I ever going to use this? So, well, I mean, from my own perspective, because I've helped tutor university level mathematics courses, I find that there's the students who can just take something and run with it, and they completely understand the concept, and there's often people who struggle a little bit to what's this coefficient mean, or what exactly is this particular symbol regarding. And so with those, I find with those guys it often helps if you try and either break it down into something they can relate to, real world terms, or in particular I found that a lot of people they feel intimidated, they feel scared by mathematics because it looks daunting. I mean, face it, if you come into a classroom and there's a page full of numbers on a sheet, and you've been telling yourself for years that you don't like maths, you're no good at it, and it's in your head, and of course you're going to be daunted. It's daunting looking at these things. So I think if you can get across the point that, hey, this stuff isn't that difficult, it's just like learning another language. And learning another language can be tricky, but once you've got it and you can speak it fluently, hey, you can string a sentence together, you can write a book if you want. So I guess it's the same with mathematics. It's just like learning another language, and yeah, different people find it difficulties at different levels. So delivery is really important, and I think you've got to, for me, I'm teaching to university level students, you've got to try and pick out what level people are at, and And sometimes there's the people who are afraid and they're really worried, or there's the people who are a little bit more comfortable but they need a little, and I guess so it is trying to identify what level people are at, and really you've got to have a lot of encouragement. And I think if I think back to some of my lecturers who I found, often the most, most formidable, but also have challenged me the most, and I've seemed to have, been very rewarding, are the ones that are constantly engaging with students and constantly asking questions and keeping your brain awake. And often I remember from school, my personal experiences where you'd be thrown in a classroom, they'd say turn to page 254 and solve questions A, B and C, and you think, oh God, I'm so bored right now. But if you're at the university level, I found, if you're sitting in a lecture or a tutorial and people are constantly engaging you and asking you questions, keeps your brain awake and it makes you feel included, so I like that.